I think it's time for me to call out back Alex Debrie and Miles Ward back to our stages. So welcome back, guys. Thanks so much
Howdy.
for sticking around with us. I mean, now is the time where basically we are going to have this round table, nice conversation, and we do encourage the audience to post questions in the chat so we can discuss about them. So uh, I think my first question is going to go to you, Alex. I basically spoke about several limitations on DynamoDB, at least from my perspective. And I do, since you love DynamoDB, I do would like to ask you two things. First, was I wrong on something? And the second thing is, what's your take on those some of the points I mentioned? For example, not being able to create a local secondary index or
Yeah.
400 kilobytes item size limit.
I mean, 400 kilobyte item size limit. Like, if you want an item that big, I want to talk to you and understand like what you're doing there. Like, is that something you need in a database? Like, that's like, how many different varied access patterns do you have on that item, and is that something that's better in sort of blob storage? So, I'd be nervous about a 400. So I don't see that come up a whole lot for folks. The thing about local secondary indexes, I usually recommend people don't use them because of the limitation that you mentioned, but also some other limitations for you. You asked like why? Hey, why can't we change it later on? So I think some background there is interesting. Like, basically under the hood, Dynamo is going to split your data into like let's say 10 gigabyte chunks, and that's not hard and fast, but generally they want to keep it under 10 gigabyte chunks. And what they also want to do is keep all the records with the same partition key together generally. And so with these local secondary indexes, what you're doing is sort of re-indexing records with the same partition key. So they want it to be all on the same storage node for that. If you come back and add a local secondary index later, it's possible that they have, maybe you have a set of records that has grown significantly beyond 10 gigabytes. A set of records with the same partition key that's grown beyond 10 gigs. Maybe you have 100 gigs of data, and now they can't sort of put those together in a clean way that gives you the strong consistency guarantees on reads from local secondary index. So that's the big thing on why you can't add one after the fact. Like, your data just might not fit that shape anymore, because once you do have, if you have a table that has one, there's going to be some limits on what you can do with an item collection, basically a set of records with the same partition key. So that's why they're not going to let you change it after the fact, which is like, that's pretty like deep down in like the nerd. Like, you probably don't have to know about this stuff, but I would say in general, you probably don't want a local secondary index. I think global is going to work best for you in most cases.
Okay. No, thanks for your feedback.
And globals you can add at any time. You can take away, all that sort of stuff. So, hey, lots of flexibility with global secondary indexes.
And as you said in your talk, I mean, only use them if you need it, right?
Yep, exactly. Any type of index, I would say only, it's going to cost you. So make sure you're like willing to, make sure you're going to get the benefit from that extra cost, right? Like, don't be hanging a bunch of additional indexes around. I think that happens a lot with relational databases, and you don't see it as much because you probably have enough capacity on your instance anyway. But Dynamo, that cost is very direct to you. So make sure you're actually getting the value from your indexes.
Miles, now next, do you want to add something? Sorry. Nope. Okay. My question to you is basically this. Today we have been talking a lot about DynamoDB and then migrating those workloads over. And I think, of course, I spoke lots about ScyllaDB, but you and we spoke both about when some reasons when ScyllaDB may not be actually a good replacement for Dynamo. So considering I'm migrating off of AWS, so I cannot use Dynamo any longer, how would you, what would be your recommendation on how people should assess, okay, which database should I pick next?
Sure. I mean, it absolutely depends on the query and access pattern, the replication requirements, availability, durability requirements, the nature of the data type that you're working with. There are a huge, there's whole categories of databases, let alone the individual products that are involved. And I think, a lot of the questions that we've gotten in the chat reflect this. not only like an urge to better understand, but a general confusion about, is this an OLAP thing? Is it an OLTP thing? Do I have a thing that feels sort of classically NoSQL? Is this more of a KV workload? Am I, so there's so many options that very often early in a project, if you're getting started, you're going to want something that can sort of impersonate several of those capabilities. No one database does all of these systems easily well, but it's pretty damn hard to do efficient joins in a big old school relational database where, Scilla does that relatively well. It's pretty hard to do, big analytical queries on a pure KV system like that. That's cost prohibitive, but ScyllaDB does that relatively well. So a lot of the most popular databases got that way, not because they are deeply specialized for a single workload, but because they work pretty good for most of the stuff you're doing. Now, if you're in the opposite situation, you already have for your system on AWS, this stuff sits in Redshift, this stuff sits in S3, this stuff sits in, Aurora, this stuff sits in DynamoDB. If you're already breaking this down by workload, you're going to start and probably correctly looking at mere analogs to those services, either in the other cloud providers that you go to or in the broader open source community. And for most companies that go from I'm in one cloud and I'm going to go to another one, it's not like they completely turn the first one off. Very often this is about bringing in a new company that they've acquired or meeting a customer where they are as they add. So if you're not going to stop using DynamoDB and completely move over onto something else, that sort of begs the question, well, hold on. Can I only have like one operational context? Could I have just like one way of reasoning about the development? So simplifying on tools that can run everywhere is a pretty strong power move. There are trade-offs, of course. You bear some operational responsibility and some complexity there, but that's for each company to decide.
Okay, thanks. Very insightful answer. Yeah, very in depth. So I can say we already got some time for audience questions. Very good. Let me take the first one from Ashley. How does token shared awareness work with ScyllaDB Cloud? Don't all requests to ScyllaDB go through a load balancer as well, or are you talking directly to your end node? That's a very good question. So remember when I said that ScyllaDB is basically a distributed database? What happens is that, particularly if you are using the Cassandra API, the overall idea of a distributed database, or actually a distributed system in general, is that how is data and how are your requests basically distributed? There's this concept which is called consistent hashing, where some of your nodes will only own a specific portion of your total data set size. DynamoDB also does that under the hood. Consistent hashing is basically how distributed applications are made. But with ScyllaDB specifically, when you connect to your cluster, the drivers will fetch all your topology, so it will know which nodes are responsible for which partitions, and when you query, the driver will efficiently route it to the correct node, which in turn eliminates round trips across replicas and helps with latencies. Okay. Going back to the DynamoDB API, currently there's no way for token/shared awareness to work. But the load balancer is pretty much a round-robin kind of thing. So you connect to Scylla, and your application will basically be doing round-robin queries against your node to ensure that your requests are balanced and that your nodes are used equally. All right. Hope I addressed the question. Alex, a question for you from Sanjeev. Does the sort key help in distributed the partition load in case of composite partition key?
So not as much as your partition key is going to help. Basically what happens when you have a table with a composite partition key or composite primary key, they're going to use that partition key mostly to determine which storage node that your record is going to. And then for all the records that have the same partition key, they're going to order them according to that sort key. Now, some changes they've made over the last 5-6 years now is, they'll do a better job of sort of splitting an item collection. So a set of records that have the same partition key, they'll split them across multiple storage nodes if they need to, which could be either because, hey, that item collection has gotten too big. It's exceeded 10 gigs. We want to split it across a bunch of nodes. Maybe that item collection is just getting too much traffic, right? So maybe you don't even have that much data there, but it's getting a bunch of reads. They want to split it across multiple storage nodes so you can just increase the potential throughput for that. So just different things like that, they might do it. So is the sort key going to help? You know, potentially, I guess, in the sense that like, hey, an item that's maybe at this end of your short key range could be distributed to a different partition key or a different storage node than one at the beginning of your short key range for a given partition. But generally, it's going to be that partition key that's going to do a lot of the work for you.
Perfect. Thanks. Question from Pratik. I see Miles went ahead and explained it already that ScyllaDB can be run whatever you want, any cloud, any environment. Is there anything else you'd like to add to that question, Miles? I mean, we worked really nicely with other customers in doing those sort of migrations. Thoughts?
Sure. One of the important things is you're talking about moving it to a region. And of course, you can run it in more than one. That's why replication is so great. You can set up an environment where maybe if you have a lot of East Coast customers and West Coast customers, like, you know, many other businesses on Earth, then you may want to replicate in that kind of way to reduce query latency for applications that sit on those. Maybe you have some customers that are, you know, in Europe and you want to replicate across the Atlantic. Those kinds of considerations make a big difference. You also very often, you know, we get customers that, you know, have regulatory pressure to ensure that they don't go offline if a single cloud goes offline. So, okay, now you want to be in more than one cloud provider, or you want to be in more than one legal jurisdiction. You know, if I get messed with in the United States, I want to be able to have, you know, governing law in the UK or governing law on the mainland cover what we do, or in Asia. So important to be able to use all of that replication flexibility to accommodate all the needs that you've got.
I have a question to you with regards to that. Considering I'm moving to a different cloud, how do you guys assess the performance, whether the performance matches between one cloud to another? Because, of course, there are similar offerings, but at the end of the day, the hardware is different, the performance is different, etc.
Well, all of the major cloud providers work really, really hard at making it so that regional systems are largely interchangeable. Their customers demand that. In particular, that the instances, if you have a i3 instance on AWS in one region versus another region, those are provisioned out of the same infrastructure components. They work the same. It's when you move into managed services like DynamoDB, where now it's AWS that's responsible for provisioning the infrastructure that sits behind a table or a cluster of tables or whatever the rest. And necessarily, some of the regions are bigger than other regions, have more redundancy than other regions. Like on the Google side, for example, like the Frankfurt region is smaller than the region in Belgium. It just is. So, you know, if you're trying to build a system that's built on the managed tools in those environments, that's just necessarily the operators there have more to work with to be able to performance optimize. It's also critical. That's one of the kind of trade-offs. If you're, you know, working with ScyllaDB open source and you're deploying and managing it yourself, those are all your decisions to make, your optimizations to arrive on. You can run it any way you like. When you work with Scylla Cloud, they have all of the tools the cloud providers have to think through all the different options and optimize the way they think is best for their customers. So worthwhile to look at all the different configuration capabilities that are possible.
Yeah, thanks. Perfect. Moving on our roundtable, I guess it's up to me to take the next question, and I'm going to take Brad's question. How do the cost structures of DynamoDB and ScyllaDB differ, particularly in terms of pricing models for read, write operations, storage, and data transfer? So both Miles and I, we actually spoke very in depth on that during our talks. But the overall idea is that DynamoDB, and Alex, correct me if I'm wrong, but it's basically a serverless offering, right? Whatever you consume, you are going to be paying for it. You do have the option of, for example, provision a pricing which, as Alex showed in his presentation, it requires a bit of mathematics for you to see if it makes sense for you or not. But at the end of the day, that's it. And if you are, for example, on demand mode, your price may fluctuate as your traffic fluctuates. While on ScyllaDB, I mean, we do not necessarily charge you per operation. You basically get a cluster. This cluster can do this capacity. It has this amount of storage, and it has this fixed price. If you need more, you add more nodes. Then of course your price changes. But at the end of the day, if your traffic fluctuates over time, the price that you'll be paying upfront in the end is going to remain the same. Did I screw it up, Alex?
No, I think that's right. Yeah, I mean, basically with Scylla and most databases, you're paying for like a cluster of or like a basket of resources, some CPU, RAM, storage. With Dynamo, you're paying for the ability to do certain size reads and writes against your database. So it's really a different model of thinking about how do I build this thing? So like you talked about data transfer in there. You're not really paying, like Dynamo's, replicating across multiple nodes behind the scenes. You are not directly paying for data transfer with Dynamo, but that is baked into the write cost of Dynamo, right? Because they have to replicate across different AZs there. So yeah, it's just a little different on how you approach that sort of thing.
Yeah, no, that's totally makes sense. Yeah, I mean, talking about network costs specifically, Miles, is this a concern that is often raised to your customers? I do know that at least here for ScyllaDB, when people engage with us, they do ask how ScyllaDB is provisioned. For example, ScyllaDB by default is provisioned in 3 availability zones, because if one AZ fails, you have 2 up available. Basic of cloud architecture, right? Do people typically ask that? I mean, how you typically try to balance and explain then what's the trade-off?
So there are lots of trade-offs. There's a great map by Corey Quinn that has like all of the hysterical sort of lines between all the different places and how much those things cost. I remember drawing much uglier, more terrible versions of that years earlier for customers trying to noodle through this thing. The reality is there is no spot. If you've ever built a data center before or you've been in one, you go to a big rack full of machines and there's this stuff at the top, racks and switches and firewalls and all sorts of componentry that connect the computers. And you'll note when you go to a cloud provider, you just don't pay for any of those. They're completely abstracted away. They just don't exist. If you know how much a Nexus 9000 data switch, an internal core switching system, those are multi-million-dollar devices just for the switching part. So we all get all of that stuff for free. And it's not really free because we pay for it per gigabyte as we transit data across all these different interfaces. So it's just a different model, in the same way as with DynamoDB, you pay per the queries that you write rather than the resources that you provision. Cloud's made it so that they use network transfer as a way to capture the costs associated with all the network equipment. The important to note, of course, that those prices, like the prices for different kinds of reads and writes in DynamoDB, vary radically. So, you move data inside of a zone from machine to machine, that costs no pennies. You move it out to the public internet, it's like tens of pennies, right? So really, really important when you're modeling moving around petabytes, because those numbers become hundreds of thousands of dollars. So lots of the tools for optimization are working to move bytes that would otherwise move out the public egress, right out the front door, the most expensive door in the cloud, to other channels that are lower price, but provide the same kinds of utility, right? So move out of a dedicated interconnect and into a local co-location facility where you procure your own network bandwidth. That's going to be 3 or 4 cents a gigabyte, or lower, depending on the kind of throughputs that you're looking for, as opposed to 12. Those kinds of where and how you buy make a lot of difference on how much you'll end up paying.
Wow. I never thought about all this. How do you know all this?
I think I'm the only one in the call who's been in the Google data centers and the AWS data centers, so I've like
Probably.
literally touched it. I can tell you exactly. I sold software to the Microsoft team, and they let me walk into the Global Foundation facilities and install a machine with the software on it, which is how you know probably you shouldn't run on Azure. I'm just throwing it out there.
Yeah, can we cut off this part of in the recording place?
Yeah,
Let me
this
yeah.
is a long time ago. I'm sure they're way better at it by now, but maybe not, given the experience of local folks with this whole CrowdStrike thing. Oh boy.
All right, moving on. Question about auto-scaling. Alex, I assume that's for you. In the context of auto-scaling read and write capacity, how can one accurately predict the impact of sudden traffic spikes on costs? And then follow.
Predict it. Yeah, that's a good question. I think I'm not as familiar with like the AWS tools on that sort of stuff, so I think you probably have to run the numbers. But ideally, if you're doing some auto scaling, you're setting a min, you're setting a max, you're setting some sort of scale number. You could get a sense of hey, what's that going to look like? And I think over time you'll start to like tighten that in and things like that. In terms of, one thing I really like about Dynamo is I like spreadsheets. I feel like you can do this in a spreadsheet fairly easily. Like you can use some of the calculators they have, but I think I don't know, they're a little tricky, I think, to use, where I just think, hey, if you have some intuition and understanding of how your application works and how to use a spreadsheet, I think you can dial some of that stuff in yourself pretty well.
Yeah, perfect. And also remember, there is milestones, which can help you to observe whether you are throwing money away or not. Yeah, so let's call it optimize your costs. Yeah. Question from Priti. We do frequent database changes via Terraform. Okay. How can ScyllaDB help optimize costs compared to DynamoDB, especially when scaling? Also, how well does ScyllaDB integrate with GCP BigQuery for analytics in this context? So let me answer the first part of your question. One of the things that you need to remember, Preeti, is as I spoke, ScyllaDB is going to be very economically viable compared to Dynamo when you do have high throughput, which is basically going to be able to make use of the hardware, the infrastructure that you provision. So typically, most deployments, ScyllaDB deployments, you don't need to worry about auto-scaling at all, because a small ScyllaDB cluster is already enough to get to pretty much unlimited, not unlimited throughput, but a very high throughput compared to what you would spend with Dynamo. Either way, as I said in my presentation, there may be situations where you want to scale quickly, like 5x, 10x, 20x. In that case, you can continue using Terraform to simply provision new VMs and start adding those nodes to your cluster. And boom, that's it. You've got auto-scaling. Second part of your question was related to integration with GCP BigQuery for analytics. It would be pretty much as you would do with any database. You have several options, right? If you have, for example, something like Kafka, you could write to both databases at the same time. If you want ScyllaDB to be your main source of truth, you could use CDC, and then whenever a write or a mutation comes into your ScyllaDB database, you stream that data to BigQuery and you take it from there. So there are many options you could do that, but at the end of the day, it depends on your application requirements. And I would like to ask for Miles' opinion on that. I mean, how would you typically do it, Miles, doing integration database to GCP BigQuery, since you know a lot about GCP?
Yeah, I think for most of our customers, this is the dual write pattern is the one that they'll follow. There's let the application do the work of writing to your logging or your analytics system at the same time as it's writing to transactional tools. If the change rate is super, super high on transactional tools, then you can do things like, taking a read-only replica or doing a database backup and restoring that backup and reading from that much lower. There are very few use cases where your analytical workload needs to be as close to real time as your application workload. So even saving a couple of hours or a day of delay, if that's enough, that's, huge reductions in the cost of doing this kind of stuff. So you got to figure out whether you're really making money on super low latency access to those kinds of analytics.
Okay,
I
that's perfect.
have a follow-up for, I guess, both of you on the beginning of that question. Do you see a lot of customers that do sort of scale their Scala clusters up and down frequently, up and down, or are they pretty static? Like, what's that sort of, I guess, like, how do you break that up? Is that a majority? Is that like pretty rare? Like, what's that look like?
Different customer of ours than Digital Turbine. They, I don't think they're a public reference yet, but it's a 3D manufacturing appliance. And for them, they have like absolute, like stair step, totally predictable diurnal variability. Morning time, everybody shows up and bangs a bunch of stuff. They all go to work. And then in the afternoon, everybody shows up, bangs a bunch of stuff, and then they all turn them off, right? So they can do it by time zone. It's completely obvious. And they have not only pre-scheduled scaling for their clusters so that they can, spin down when they know they're not going to need them. And they have a small amount of auto scaling on the front ends to be able to accommodate if there's unpredictable levels of change.
Yeah.
But yeah, happens all the time.
Yeah, and I mean, we are almost out of time, but also to add to your question, Alex, in general, you do not want to be scaling up and down every often, even in Dynamo, right? You want to have enough capacity so you can sustain some sort of traffic. But I can give you some examples of some other customers here that are actually interested in doing that, because as I said, tablets was recently a new feature. But so for example, iFood is basically like the Grubhub in Brazil. And as you can imagine, people don't order food like 5 a.m. Well, very few people do. So typically they will say, okay, well, I don't need that big capacity, so let's scale down. And during peak hours like lunch or dinner, that's when the really traffic begins, and that's when they scale up further. Another one is ShareChat, for example, very famous in India, social network like a TikTok app, if I recall correctly. But anyway, ShareChat. During India prime time, things are crazy. They need tons of capacity. When it's outside in the prime time, maybe having all this capacity provision is eventually an overkill, right? They're basically, the infrastructure is sitting there idle, and they're incurring costs as they go. All right.
Very cool.
So, guys, Miles and Alex, thank you so much for being here today. We need to wrap up. Time is up. And guys, please follow on both Alex and Miles on their social networks.